In this video, we're going to talk about transformations of exponential functions. Transformations are very similar to the transformations we've done with quadratics, absolute value, polynomial functions, all that kind of stuff. So h is going to be your horizontal shift. So positive shifts it left, negative shifts it right. K is going to be your vertical shift. Positive shifts it up, and negative shifts it down. If A is negative, the function is the reflection across the x-axis. If A is greater than 1, it's a vertical stretch. And if A is between 0 and 1, it's a vertical compression. So number 1 here, the parent function, so the A part of this, f of x is 3x, 3 to the x, and B, it moves up 5. The parent function for 2, f of x, equals 1/4 to the x, and B, the transformations, it's a vertical stretch of 2, and it goes to the right 1. So that right there. 3, my parent function is f of x equals 4/3 to the x, and my transformations, it reflects over the x-axis. Goes left 2 and up 7. 4, my parent function is f of x equals 5 to the x, and my transformation is a vertical compression of 1/2. It goes right 4 and down 2. That should be a 2 not. Alright, so now we have to graph some. So that's why we wanted to worry about our parent functions first. So this will be 2 to the x, and this will be 2 to the x plus 5. So we'll still have -2, -1, 0, 1, and 2 on both. So -2, actually, I lied, we won't have those here. So, because we're adding it to x, so it'll change to x. Y will be 0.25 or 1/4, 0.5 or 1/2, 1, 2, and 4. If we go back and look at the notes that we just took on the last pages. So now since we're changing the x, we're going to add 5. So our y's won't change. It'll be 0.25, 0.5, 1, 2, and 4. And we are going to move everything left 5. So that means I'm going to subtract 5 from everything. All my x values. -7, -6, -5, -4, and -3. So this one is the one that I want to graph. So it's just going to shift everything, that 2 to the x, over by 5 units. So it's still the same function, just shifted. Same shape and everything. So there's my function. Now let's talk about some characteristics. So my domain is all real numbers still. My range is still going to be greater than y. Y is greater than 0. My in behavior as it goes to positive infinity will still be going to positive infinity. As I go to negative infinity will still be 0. The y-intercept will be the thing that changes, because that's where x is 0. So 2 to the 0 plus 5 is 2 to the 5th, which is 32. So 0 to the 32 is my y-intercept. And my asymptote is still y equals 0. So let's do at least one more of these. Let's do 2 more. We'll do 6 and 7. And we'll leave 8 and 9 for the reader. For you to do. Alright. Let's draw our little t-tables here. So x and y. So this will be 1/3 to the x, and this will be 1/3 to the x minus 2. Let's stick with our -2, -1, 0, 1, and 2. This time, since it's going down 2, it's going to change our y's, not our x's. -2, -1, 0, 1, and 2. So we can deal with that then. So when I plug them in, I'm going to get 9, 3, 1, 1/3, and 1/9. And then I'm going to want to subtract 2 from everything. So I'm going to get 7, 1, -1, -1.6 repeating, and -1.8 repeating. So when I graph these, we want to graph the second table, not the first one. So this is going to change a couple things, which we haven't changed yet, so not a whole lot, it'll just change a few things. Domain will stay all real numbers. Range is going to change because you see how before we stayed, we'll do the before. Before we were all on the y, on the x-axis, but now we're down here at -2. So y is greater than -2. Our in behavior, as x goes to positive infinity, f of x goes to -2, where before it went to 0. And then when it goes to negative infinity, it's going to positive infinity. Excuse me. And then the y-intercept is 0, -1. And our asymptote and our range are going to be identical in the number sense. So it'll be y equals -2. So let's do number 7. So let's do our parent function, which is 3 to the x, and then we'll deal with the other one. xy, xy, 3x, and this is going to be f of x, this long thing. -2, -1, 0, 1, and 2. So when I plug in that, I'm going to get 1/9, 1/3. It's opposite of what the 1/3 to the x was. 1, 3, and 9. Alright, now when I add all of this fun stuff to it, so I'm going to take it, these numbers, take them in half, and then add 1. So my x's aren't going to change because I'm not doing anything with this little x up there. I'm just hanging out with the y. So it's going to be 1.05 repeating, 1.16 repeating, 1.5, 2.5, and 5.5. And decimals are okay in this one because it's easier to graph if they're decimals. So -2, 1.05, 1.16, 1.5. And these, I won't graph, like, as long as your graph looks similar and it's going the right way, I'm not going to grade you on your halves and all that, as long as it's close and all your information's right. Three. So that's would be your function. Hopefully yours looks a little bit better than mine. Your domain is going to be all real numbers. Your range is going to be this little guy right here. Y is greater than that guy, which is 1. As x goes to infinity, it's going to positive infinity, and as it goes to negative infinity, it's going to 1. Your y-intercept is 0, 1.5, and your asymptote is y equals 1, because that's the line it gets really, really close to, but never crosses.